Welcome back to this lecture series on power plant economics. A quick recap of what was done in the earlier lectures. In the earlier lecture series, I talked about what is the concept of capital cost, which plays an important role in deciding the cost of electricity generated. Capital cost is the initial investment which is made in the power plant, and using the capital cost and knowing the rate of interest at which the capital is borrowed uh, would decide what is the fixed cost. So the initial investment made in the capital in the power plant and the rate of interest prevailing in the economy, we can call it as a borrowing rate, that would influence what is known as a fixed cost component of the cost per unit of electricity generated. So that was discussed earlier. And another important component of the cost per unit of electricity generated, the economics of power plant, is the variable cost. And we said that the variable cost is influenced by the cost of the fuel which is consumed. This is especially true when you are talking about the plant which consumes, a power plant which consumes fossil fuel, let us say, for example, a coal-based power plant. Okay. Obviously, this would not be a major factor when you are talking about renewables, where we don't have the fuel consumption per se. Okay, but the major power plants, which are unfortunately today the fossil fuel-based power plants, that have this fuel cost as a major factor in the variable cost. Obviously, operation and maintenance would also influence the variable cost, and this together, I mean the variable cost and the fixed cost, this together would influence the cost per unit of electricity generated. So this was discussed in the earlier lectures series. Today what I plan to do is to give you an insight of what is known as diversity factor. This is a very interesting concept, and a short video, okay, which I have planned for today's lecture. That is to explain you this concept of diversity factor, and also we would plan to discuss using an example the relevance of the load factor and capacity factor in which influences the economics of the power plant. So what is diversity factor? That we would all love to understand. To give you a concise definition of what is diversity factor, don't worry, even if you don't understand this definition, it would be clear as I give you the example of that. So diversity factor is defined as it's basically a ratio. It's a ratio. Obviously, when you are talking about a ratio, it would have some term in the numerator and some term in the denominator. So what is in the numerator is the sum of individual non-coincident maximum demand. So for example, if you are talking about some four set of demands, okay, so demand 1 plus demand 2 plus demand 3 plus demand 4, those are to be added, and that sum is in the numerator. And this is a coincident demand. We are not non-coincident demand we are talking about. And then the total demand, the maximum demand, would come in the denominator. This will understand when I take an example of this. Okay, so just remember this definition, that it is the ratio of diversity factor is a factor. It is a ratio. It is a ratio of the sum of individual non-coincident maximum demand of various subdivisions, okay, of various loads, and divided by the maximum demand of the complete system that is in the denominator. Okay. And this diversity factor is useful because if you want to plan the dispatch of the load, or if you want to decide upon the new load addition in the power plant economics, especially when you are talking about transmission and distribution part of the power plant, there this parameter is very important, because we know that if you because all the loads, all the consumers do not consume simultaneously, okay, and hence all the subdivisions or all the consumers are never simultaneously at their peak load. This understanding would help us in designing that proper transmission and distribution system of the power plants. Okay, so how is that? So I'll take an example to clarify this a bit. So just remember, what is diversity factor? Diversity factor is a ratio. And what is the ratio? It is a ratio of sum of individual non-coincident maximum demand of various subdivisions of the power system upon the maximum demand of that power system. Okay, so what is to be understood is, with the help of example, let us say that there is a location. Okay, there is some place, let us say there is some hotel or some place where there are air conditioners used. Okay, and let us say that those air conditioners are consuming 1 kilowatt of electricity. Okay, and let us say that that 5 AC, those of this 10 air conditioners, let us say that 5 air conditioners are located in a office. Okay, and the remaining are located at the households, as the residences. Okay, you understand that. Just to take a location of your city wherein there is a commercial space as well as there is some residential space. Okay, and assume that this commercial space and residential space is connected to some substation. Okay, and what we have taken as an example is, we are assumed that the commercial space has got 5 air conditioners of 1 ton capacity, and each air conditioner is consuming 1 kilowatt of electricity. Its power rating is 1 kilowatt. And the remaining 5 air conditioners which we are talking about, they are located in some bungalows which are around, the residences which are around, and they also have the same capacity, 1 TR, which would consume 1 kilowatt each. Okay, so in this way, if you just do the totaling of it, so 5 plus 5 from the commercial space, that is offices, and 5 from the residences, that is homes. So that 5 plus 5 becomes 10, and hence the total connected load becomes 10. Okay, now if you take the diversity factor as 1, okay, then what would that mean? If the diversity factor is 1, it would mean that all these air conditioners, that is the air conditioners in the offices as well as the air conditioners at the homes, okay, at the residences, they are on simultaneously. They are on simultaneously. Okay, they are operating simultaneously. Now, this is not a very realistic scenario. You understand that. For example, you might find that in the afternoon period, the offices are loaded, okay, with air conditioners, whereas in the evening, for example, it could be that the residences would have their ACs on. Okay, so obviously it would depend upon the location to location. But this understanding, that is, what is the diversity factor? How much of this load is coincident and how much of it is non-coincident? Okay, coincident means all of them are operating simultaneously, and non-coincident means some of them are not operating simultaneously. Okay, so how much of this load of this 10 kilowatt is coincident? That is told by diversity factor. So when your diversity factor is unity, it would mean that the coincident load, okay, is all the entire load. So the entire load and the connected load and the coincident load is the same. Okay, so that obviously is not always the case. So that is what we said, that it is that, just a minute. We know that ACs are not always having the simultaneous. ACs means air conditioners are not having the simultaneous demands. Okay, so we suppose we keep the diversity factor as 1.2, then obviously the maximum load, okay, the maximum load would be different. Okay, and that would be the maximum connected load. So we did not connect the system to a 10 kilowatt transformer. Okay, we might connect it to a less kilowatt transformer. So 10 upon 1.2 would be 8.3. So instead of installing, or instead of having a capacity of 10 kilowatt, which would have been the case if the diversity factor was unity, we would have instead a connected load which is much more manageable. Okay, that is 8.3. And how is this 8.3 calculated? So 8.3 has been calculated by taking a diversity factor of 1.2. Okay, so with unity diversity factor, it would have been 10 kilowatt, and now because it is greater than unity 1.2, it has come down to 8.3. Okay, so this is how the diversity factor understanding helps us in designing the power plant system, and it is obviously going to influence the capital cost, because less is the connected load, less would be the capital investment, and that is going to influence the capital cost of the power plant economics. Okay, so this is what is to be understood. Okay, for example, I had taken one short example. You can just open your notebooks and take down this numerical. Let us say that there is a system, and that system has got a peak load, peak demand of 60 kilowatts. Okay, and the individual demands, the individual maximum demands are, there are 4 loads, and one is 30 megawatt, second is of 20 megawatt, third is of 10 megawatt, and fourth is of 14 megawatts. Okay, so how much is the diversity factor? So as we had defined, the diversity factor is the summation of this maximum demands, that would be in the numerator. Okay, so that 30 plus 20 plus 10 plus 14, that comes to be 74. That is in the numerator, and the peak demand is 60 megawatt, that is 1.233. Okay, so that gives us the diversity factor. In other words, the coincident demand is not unity, it is 60 upon 74, it is 0.8. Okay, so this has to be understood clearly, that the demand factor and the diversity factor plays an important role in planning of the power plants. And if you plan the power plant carefully, we would require less of the investment, and if the investment is less, as we have seen in the earlier lecture series, the capital cost is less, the cost per unit of the electricity also remains lower. Okay, I hope this is very clear to you. So what we have studied, okay, in this short lecture is, we have studied the concept of diversity factor, and I have stressed this point that it is very important for us to understand the diversity factor, because it is ultimately going to influence the capital investment. Okay, and if you are clear with that, then we would understand its relevance. Okay, so understand that diversity factor, demand factor play a very important role in the power plant economics, especially in influencing the fixed cost component, the capital cost component. Okay.